Question number 126. In a dorsiventral leaf, the vascular bundle is first option radial and closed, second conjoint and closed, third conjoint and open, fourth radial and open. Dorsiventral leaf means a dicot leaf. The vascular bundle is first option radial and closed. No, radial vascular bundles are seen in roots. So first and the fourth options are ruled out. Third option, conjoint and open. Open vascular bundles are open for secondary growth as they have cambium. But we cannot see secondary growth in leaves. They do not show secondary growth. So they are closed. So this is ruled out. The vascular bundles in the leaves are conjoint. Yes, means xylem and the phloem are present together. And the vascular bundles are closed too. Yes, because they lack cambium. They are closed for the secondary growth. So the correct option for the given question is option number 2. Let's move on to the next question. Question number 127. The parenchymatous cells which lie between the xylem and phloem seen in a section of monocot root are called first option medullary rays, second bast fibers, third conjunctive tissues, fourth secondary tissues. Here it is the section of a root. In this question, it is asked that the parenchymatous cells which lie between the xylem and the phloem in the section of a root are called. So this is phloem over here and this is xylem, this is metaxylem, this is protoxylem. So protoxylem is present towards the outer side, metaxylem towards the inner side. It is the exact type of condition. Now, as this is the section of a root, the cells which are present between a xylem and phloem are seen in the yellow color. And these are parenchymatous cells, and these parenchymatous cells which are present between the xylem and phloem are called the conjunctive tissue. So this is correct. Medullary rays, no. In stem, the parenchymatous cells present between two vascular bundles are called the medullary rays. So this option is ruled out. Bast fibers are the phloem fibers. This option is ruled out. Secondary tissues, no, these are not secondary tissues. So the correct option for the given question is option number 3. Let's move on to the next question. Question number 128. Starch sheath is the innermost layer of the cortex in a first option dicot root, second monocot stem, third monocot root, fourth dicot stem. So starch sheath is the innermost layer of cortex. The innermost layer of cortex is known as endodermis. This endodermis is called the starch sheath in. In case of monocot stem, endodermis is absent as ground tissue is not differentiated. So this option is ruled out. In case of dicot and the monocot roots, the endodermis does not store starch grains. Hence, the endodermis is not called starch sheath in roots. So these options are also ruled out. Fourth is dicot stem. Yes, in case of dicot stems, the endodermis may store starch grains, hence called starch sheath. So the correct option for the given question is option number 4. Let's move on to the next question. Question number 129. In a monocot root, first, formation of entire vascular cambium takes place by the cells of pericycle. Second, hypodermis is absent. Third, pith is small or inconspicuous. Fourth, endodermis is not distinct. In case of monocot root, the formation of entire vascular cambium takes place by the cells of pericycle. No. Monocots do not show secondary growth. If they do not show secondary growth, there is no presence of cambium. So vascular cambium does not present in the monocot root. So this option is ruled out. Third, pith is small or inconspicuous. This option is also ruled out. Why? Because in monocot root, the pith is large. It is very distinct. It is very clear and conspicuous. Fourth, endodermis is not distinct. In case of monocot root, endodermis is distinct. So this option is also ruled out. Second, hypodermis is absent. Yes, in all roots, including dicot roots, hypodermis is absent. So the correct option for the given question is option number 2. Let's move on to the next question. Question number 130. Heartwood differs from sapwood in first option being lighter in color, second being actively involved in conduction of water, third providing mechanical support to the stem and not conducting water, fourth having lignified cell walls of trachea. How the heartwood differs from the sapwood? You may be knowing about it that if you see the mature dicot stem, you will find that the peripheral region of that wood is called the sapwood and the central region is called the heartwood. And this wood is nothing but the secondary xylem. This sapwood is lighter in color. So first option being lighter in color, no, heartwood is not lighter in color, it is darker in color as compared to the sapwood. Second being actively involved in conduction of water, no. Heartwood is dead due to accumulation of organic compounds, hence it is not used in conduction of water. Sapwood helps in conduction of water. So this option is also ruled out. Third one, providing mechanical support to the stem and in not conducting water. Yes, the heartwood does not conduct water but it provides mechanical support to the stem. So it is correct. Fourth one, having lignified cell walls of tracheids. In both heartwood and sapwood, the tracheids are lignified. So this is also incorrect. So the correct option for the given question is option number 3. Let's move on to the next question.